Hello, I'm going to be working on this recursion problem. Uh, it's a permutation problem involving recursion in C. Just to be transparent, I am not an expert in this. This is more so just a video for me to practice explaining how I solve this problem, just so I myself can have a better understanding of it. So I don't know how helpful this will be as an actual tutorial, but I from the videos that I watched on this, I did this differently, and I think the way I did it personally helped me out more because I basically like brute forced it, I guess. Because I find that when I write down every single step, it allows me to understand the problem better. So yeah, so hold on, let me just make this bigger. The way I did it took a lot of space up. All right, so what we have here is a permutation. It's a basic one. Um, Basically what we're doing is we have ABC, the string, and we're trying to find all the possible permutations of it. So if we were to do it like by hand by ourselves, we get ABC, ACB, BAC, BCA, CBA, and CAB. Like that's how you do it by hand, and that's notice how that's six different combinations. Um, Also, if you didn't know, Um, notice how there's three characters. Six is the same as 3 factorial. So like if we had like A, B, C, D, E, if you wanted to find the combinations for this, or sorry, like you wanted to find how many combinations there are for this, it would just be 5 factorial. Um, but then that becomes a lot of work to do by hand, so that's why we have this magical recursion problem that does it for us. Okay, so that's what we're trying to do, and we're going to use recursion to figure it out, to have it do it for us. Um, so we're gonna write down ABC. Right now, I'm just gonna write the parameters that we're sending to initialize the problem. So we're sending str, which is ABC. We're sending 0, and we're sending n minus 1, which is 3 minus 1, which is 2. Bad. Whatever. Uh, okay. So what these are is it's these things. So this is string. I'll just write str. 0 is left, and 2 is right. This is basically just the indexes. So like a, sorry, string 0 is A, and string 2 is C, and obviously that's the leftmost letter, and this is the rightmost letter. Okay, so now that we have that, let's first point out the base case, which is right here, which is essentially saying when left equals right, it wants us to print the string. This base case is essentially saying when the index uh, 2 equals 2, that means that we successfully completed a full permutation and then we print it. That doesn't really make sense right now, but as we go, it'll make more sense. For now, we're just going to skip the base case because we don't satisfy it, obviously, because left is 0 and right is 2, which means they don't equal each other. So we're going to go straight on to the else case. So what I'm going to do is I'm going to write first to signify the first iteration of this whole recursion problem, because there's going to be a lot of different iterations. So I try to write down each, I try to number them so that it makes more sense in my head. All right, so we're on the first iteration. What we have is a for loop, and we have int I equals left. So let's write that down right now. So I is left. Left is 0, so I is also 0. I'm also going to write down left equals 0, just so that it's easier to understand for me. So now that we have the I set up, we're going to start with the swap. And what this is doing is it's essentially swapping the characters at those given indexes. So swap string indexes left with string index I. Now in this specific iteration, or at least right now, they're both the same. And this is essentially saying swap A with A or swap A with itself. So right now, technically the swap does nothing because it's still going to be ABC, but we're still going to write it just so that I just like to write out every single step. Okay, so now that we have done the swap, we're going to go to permute. This is the first recursion. I'm just going to write down P to signify we are doing a recursion. And what I'm going to do is I'm actually going to change the color so that it makes more sense. So now we're on the second iteration. And what I'm going to do is I'm actually just going to rewrite the parameters just so we know what we're working with. So now we have the new string, which is technically the same. Even though it was swapped, it didn't change anything. So we're just going to write ABC. Now left is actually going to be 1 now because within these parameters, everything is the same except this. Because left is incremented by 1. That's the actual recursion happening. So left is 1 now, and right is 2. It's exactly the same. Nothing happened to it, right? It will still send as right. So let's go through this again. Let's start with the base case. Does left equal right? 1 does not equal 2. So base case failed. I'm just gonna write down an X to signify that the base case failed. Also, we failed the base case here too. I forgot to write it down. We'll just put that. Okay. So now that we failed the base case, we're gonna go to the else statement. Okay, so int I equals left. Left is 1, so I is gonna equal 1. Left is also gonna equal to 1. And we're gonna do it again. So swap. We're actually gonna swap the same indexes again. It's gonna be ABC once again, and now it's time to permute once again. So we're gonna permute. I'm gonna change the color to a light blue. So we're on the third iteration now. I'm gonna once again write down the parameters. Left is gonna be 2 now because left was 1, and now we're incrementing it by 1. So left is 2 and right is 2. So let's start with the base case. You'll see that left does equal to right now because 2 equals 2. So what we're going to do is we're going to go on with the if statement, and it says to print the string. So we're going to print A, B. All right. So now that we did satisfy the base case, we're just going to completely ignore the else statement because if was satisfied. So we're going to skip that. Now this is when backtracking comes in because since we did this, there's no more recursion in this instance because we're not accessing this permute. So this is when we actually backtrack because we're not going to continue onwards. We're actually going to go backwards. So I'm going to write back, and I'm going to start using green because what's happening now, this whole blue thing was happening within here. And we didn't keep going. We're going backwards. So we're actually coming back to here, and now we're going to be on this line within this iteration, if that makes sense. That's what backtracking is because we did not continue any more recursions. We're going backwards, so we're going to end up back where we were previously. So, yeah. So we're going to go back to here, and we're going to do this swap. Notice how it's exactly the same as this one that we did here, right? It's exactly the same. That's because we are reversing what we did. We're just putting it back. We're just gonna redo it, and this is because we want to put it back so we can continue exploring different potential combinations. So let's do that. So we're gonna swap 1 1. Obviously, it's gonna be the same, but it'll be different later on. Right now, it's exactly the same. Okay, so now that we swapped, we finish this part, we're gonna go to the next iteration of this for loop. Now, keep in mind, since we're in this we're in the green, we're still using these parameters. So right now, I is 1 and left is 1. But since we're going back into the for loop, we're incrementing I by 1. So I is going to equal to 2 now. Left is still going to be 1 because nothing changed with it. So now we're going to continue with the for loop. We're going to swap. This time, we're actually going to change it because indexes are not the same. So swap left with I. Left is 1. These are indexes. Like swap index 1 with index 2. And so what that's gonna do is that's gonna change ABC to ACB, right? Because index 1, this is index 2. We just flipped them, and so now we have ACB. So now that we completed this, we're gonna go to the permute. So once again, we're gonna permute. I'm gonna do a dark blue now. The fourth iteration. Let's write down the parameters once again. ACB. We swapped it, so it changed. So it's ACB now. We're incrementing left by 1. Left was 1, so left is going to be 2 now. And right is still the same. Okay, so now we have these new parameters. Let's check the base case. It is satisfied. 2 equals 2. So we're going to print string, which is ACB. So now that we pass the base case, we're going to ignore this else statement, which means no more recursion will be continuing from this point on. So we're going to go back to the previous iteration. So we're going to backtrack to green, which means we are here now. And that means we're also continuing to use these values because we just went backwards. So this is like redundant now. Like it doesn't matter now. Like it's already been done. We printed this. We're going back to these parameters. We are ignoring these now. So we have I equals 2 and left equals 1. Now we're going to swap, which is essentially reversing. So we're going to swap 1 and 2, which makes ACB back to ABC. Okay, so now, since we still have I equals 2 and left equals 1, and we are at the end of this instance of this for loop, what we want to do is we want to go back and increment I by 1. But this means that I would equal to 3, which is not, that's greater than right, because right is 2, which means we are done with this for loop. This means there's no more permutations happening in this instance, right? Because 3 is greater than right, so this part is just not happening now. This is when we backtrack once again. What's right back? We're actually going to go back to the red. Because this was like, this was a sub-iteration of this, which was, this is a sub-iteration of this, which is a sub-iteration, okay, never mind. We're just going back. We're going back to the red. Because there's no more permutation happening within the green. So I'm actually going to write this. Go all the way back here. Go to the 5th iteration. And we are using, well, I'm going to rewrite these parameters because it's been so long. So I'm just going to like write them down again so we remember what we're working with. Left is 0 and right is 2. So what's happening now is we are back here. This is like the crazy confusing part because it's like loops within loops. But at this point, we're actually back to here in the red part, in the red iteration. Because this whole time we were like within iteration after iteration, but now we're back to the original one. So now we're gonna swap using these parameters. I equals 0, left equals 2, or sorry, 0. Whoops. So let's swap. 0, 0. That's gonna be A, B, C. Okay, now we go to I++ because we're continuing the for loop. So now I is going to equal to 1. Left is going to equal to 0 because nothing happened. It's still 0. So now we're going to swap index left, index I. So now we swap 0 with 1, which basically means we're swapping these two. So now it's going to be, instead of ABC, we're going to change it to BAC. So now that we did that, we're going to permute. We're going to permute. I'm going to use green again. Now, that doesn't mean that it is at all related to these ones. More so just the fact that it's a sub-iteration of this one. So these do not correlate with what's about to happen here. Keep that in mind. Entirely different thing. So we're permuting to the 6th iteration. Let's write the parameters down again. We got BAC this time. And left is incremented by 1 because of this. And left was 0. So now it's going to be 1. And right stays the same. So 2. Let's do the base case. 1 does not equal 2. So we're going to just skip that. I'll put an X to signify that. Let's go to the for loop. I equals left, which means I equals to 1. I'm going to write down left equals 1 as well so we can see it clearly. Let's swap. We're swapping index left with index 1. This time, it's going to do nothing, basically, because it's swapping index 1 with itself, or A with A. So B, A, C. It's still the same. We're going to permute now, because now we're at this point. Let's go to... let's change the color. Once again, this does not correlate. It does not have anything to do with this one. It's just the fact that it's a sub-iteration of this one. So let's do 7th. Let's write down the new string, BAC. Left is incremented by 1, and it was 1, so we're going to do 2 now. And right is 2 again. Let's do the base case. So the base case is satisfied because left does equal to right, or 2 equals 2, which means we're going to print BAC. And because this was satisfied, we're skipping this, which means no more permutation happens from this instance onwards. So we're going to backtrack now. Back to here. So now that we're back here, we're basically back here, right? Right here is this. So let's swap with these parameters because we're back to here as if nothing happened, as if we're back here, as if nothing, yeah, as if nothing happened. So let's swap because we're essentially reversing, of course. Happened. Even though like it swapped with itself. Still gonna do it. BAC. Okay, now that we finished this part, we're going back and we're incrementing the I by 1. So I was 1. So I is going to equal to 2 now. Left is still 1. Now we're going to swap. So we're swapping index left with index 1. So we're swapping 1 with 2, which is basically swapping A with C. Now we're going to have BCA. And now we're gonna permute once again. So let's permute. I'm gonna use dark blue now. 8th iteration. Let's write down the parameters once again. We have BCA as the string. We're incrementing left by 1, and it was 1, so it's going to be 2 now. Right is still 2. Now let's do the base case. Left does equal right, because 2 equals 2, which means we're going to print, which means the base case was satisfied. So we're printing BCA. And now that this was satisfied, we are ignoring this, which means no more permutation happens from this instance onwards. So this is when we backtrack. So we're going to backtrack to the green to this point, which is here. This here, and now we're going to swap because we're using these values again because we're just back here. We're going to swap 1 and 2, which just reverses what we did. So it's going to change BCA back to BAC. So now, note that I equals 2. We are at the end of this iteration of this for loop, which means we would increment I by 1. But that would mean that I equals to 3, which is greater than right, which is 2. So since 3 is greater than 2, we're done with the for loop, which means in this green iteration, no more permutation happens. So we backtrack again. We're going to backtrack back to the red. Man, I have to make this bigger. Hold on. Okay. Right, so we are backtracking once again. We're going to go back here. This is the 9th iteration. And just to, because it's been so long, I'm going to rewrite the parameters. Just to be sure. Because actually this time, I equals 1 right now. And left equals 0. So we are back here now, which means we are swapping 0, 1, which is going to make BAC equal to ABC because we're swapping these. So this is going to be ABC now. Now that we are here, we finish this. Now, because we finished, we're going to go back to the for loop and we're going to increment it by 1. Now, I, at this point, is 1. So I is going to be 2 now. Left is still 0. And now we continue on with the for loop with this new I equals 2 and left equals 0. So we're going to swap again, swapping index left with index I, which means we're swapping 0 with 2, which is going to turn ABC. We're swapping A and C, so it's going to be CBA. And now we're going to permute because we're at this point. So let's permute. I'm going to change it to green because this is we're going on to like a sub iteration of the red. This will be the 10th instance. Let's write down the parameters. We have CBA. Left is incremented by 1 and it was 0, so it's going to be 1 now. Right is still 2. Let's check the base case. 1 does not equal to 2, so we're skipping that. Put an X. We're going to go on to the for loop. I equals left, which means I equals 1. Left equals 1. And we're going to swap because we are going on with the for loop right here. We're at this point right now. Index left with index I, which is 1, 1. So it's actually going to stay the same. Nothing happens in this instance. And we're going to permute once again because now we are here. So let's permute. I'm going to do light blue now. 11th iteration. We have CBA. And left was incremented by 1. And it was 1, so it's going to be 2 now. And right is still 2. Let's check the base case. Yes, 2 is equal to 2. So we're going to print this string, which is CBA. And since we satisfied the base case, we are just going to skip this else statement, which means no more recursion happens on from this instance. So we're going to backtrack. So we're going to go back to the green, going back to here, below the permute one, which is this. We're here now. And we are using these values because we're back to this instance. So let's swap 1 with 1. It's going to be CBA because nothing changes, of course. And we're going to permute. Oh, no, sorry. Not yet. We're actually at the end of this for loop. So we're going to go back and we're going to increment I by 1. So I equals 2 now. Left is still 1 in this instance. And let's swap again because right now we are here, of course. Index left with index I. So that's going to be 1, 2. Which means we're swapping B and A. Now it's going to be C, A, B. Okay, so now that we did this, we're going to go here to this permute. So let's write P. I'm going to do dark blue to the 12th iteration. Let's write down the string we have. We have CAB. CAB. We're incrementing left by 1, and it was 1. So that means it's 2, and right is 2. So let's check the base case. 2 equals 2. That means it is satisfied. So we're going to print the string. Satisfied. Print. I know that like technically supposed to be printing like this, but I'm just writing the actual thing itself just for explanation purposes. I know it's technically wrong. Just so we can see what's actually being printed. That's why I wrote it like that. Okay, so now that we satisfied the base case, we're skipping this else statement, which means no more recursion happens on from this point. So we backtrack. We're going to backtrack back to below this permute line, which means we're back to here. And so we're going to swap index left with index I, and we're using these values because we just went back to here. We're going to swap 1 with 2. Basically reversing what we just did here. It's going to turn back to CBA. So CBA is what comes out of that. Okay, so now we are here, right? And because we're at the end of the for loop, we have to go back and increment I by 1. But I is 2 right now. So if we do that, I is going to equal to 3, which is going to be greater than right, since right is 2, which means we cannot continue, which means no more recursion from this point. So we're done in the green instance. That means we have to backtrack again, back to the red. So let's do that. We're going back to the red. Back here. This is going to be the 13th iteration. We have, which means we're going back to here basically, right? Which means we are here, and we are using these. So we're gonna swap 0, 2, which changes CBA back to ABC because we're swapping C and A with each other. So we're going to get ABC. And then since we are here, we're going to go back to here. And we're going to increment I by 1, but I was 2. And if we do this, I will become 3, which is greater than right, which is 2. So that means we're done with this. No more recursion will be happening from this instance. So, that means no more. We're done. We have changed it back to what it originally was, and no more recursion is happening. So we're done. So that is it. So if you look back, you'll notice we printed ABC, we printed ACB, we printed BAC, we printed BCA, CBA, and CAB. That's 1, 2, 3, 4, 5, 6. That is all 6 of the potential combinations of ABC. So that is it. Yeah, it's pretty. I'm sure I didn't explain it very well, but this video is kind of for me anyways. So if you are somehow watching this, and I hope it helped in some way. Yeah. So thank you if you did watch this. Okay, bye.